There are over 100 radio telescopes around the world, yet detailed information on radio astronomy remains hard to come by. You might argue that significant data like the WOW signal, the cosmic microwave background, and much more were gathered using radio telescopes. However, this data is relatively limited because most radio waves heading towards Earth are blocked by the atmosphere. This means that a large portion of these waves gets either delayed or reflected back by the atmosphere. This presents a major problem, making it technically impossible to access the full scope of data regarding the universe's origins. So, what's the solution to this? Well, there is one. We can place a radio telescope far away in space. You might then wonder, why go through the trouble of installing a space radio telescope when we already have several space telescopes? In today's video, we'll explore this question in detail. Hello guys, I'm Kaushik, and let's dive into another episode. Take a look at this wavelength chart, which we've shown in several of our previous videos. The shorter a ray's wavelength, the more energetic the wave is. As the wavelength increases, its energy decreases. Now, if a cosmic entity lacks any protective layer, then all electromagnetic radiation, regardless of its wavelength or energy, would reach us in its purest form, allowing us to study it directly. However, Earth has a large protective layer, the ozone layer. While this is fantastic for life on Earth, it's not so great for astronomy enthusiasts. Why? Because the ozone layer absorbs most ultraviolet rays and shorter wavelengths, and it blocks mid-range waves like infrared and microwaves. Longer radio waves also get delayed, which is why only a select few radio waves reach our radio telescopes, forcing us to work with limited data. This narrow passing range is known as the radio window in astronomy, and its size varies depending on atmospheric density and the composition at any given time. Even after this, the radio waves reaching ground-based telescopes must still pass through these obstacles, so you might be asking, if we are receiving some data, why do we need to go to space? Let's first understand why radio telescopes are more crucial than any space telescope. The dark age of the universe. Around 400,000 years after the Big Bang, the universe entered its dark age, which lasted for about 600 million years. During this time, nothing existed. No stars, no galaxies, no planets, just a fog of hydrogen formed after the Big Bang. Since there were no stars, even the most powerful space telescope or gamma-ray polarimeter wouldn't be able to capture radio waves from that era without a radio telescope. The reason is that the radio waves from that time have faded so much that, even if they reached Earth, the atmosphere would have delayed them. Thus, even the best radio telescope on Earth wouldn't be able to capture the true essence of radio waves from the Big Bang. So, you might ask, why not build a space radio telescope like Hubble, JWST, or Chandra, which have provided us with stunning images of the universe? The challenge lies in the fact that radio telescopes are not like regular telescopes. They need to be much larger to capture longer wavelengths. The older the data we aim to collect, the larger the radio telescope's aperture must be. This means that we'd need an enormous dish in space. The size of a radio telescope's aperture is directly proportional to the number of radio waves it can capture. To collect ancient data, the telescope's aperture would need to be at least 1 kilometer wide, but building such a massive dish is quite impractical. So, does that mean it's impossible to have a radio telescope in space? Not necessarily. An alternative solution would be to place the telescope on a cosmic body without a protective layer to block incoming radio waves. The two best options are the Moon and Mars. However, Mars is far too distant, and frequent dust storms could easily cover the telescope in dust, making it ineffective. So, the best option is the Moon, specifically its stable and empty surface, which is free of storms. Scientists have already identified an ideal location for it: a crater on the lunar surface. In 2021, a design for a lunar crater radio telescope was proposed with a diameter of 1 kilometer. NASA even allocated $500,000 to develop the project, and work is progressing, although the current development status hasn't been fully disclosed. The most critical detail that has been confirmed is the telescope's location. This Lunar Crater Radio Telescope, or LCRT, will be installed on the far side of the Moon, the side that never faces Earth. This location is ideal for several reasons. First, the telescope would be able to capture radio waves with wavelengths longer than 10 meters, which Earth's ionosphere currently reflects. These long radio waves could be so old that they might even date back to the Big Bang itself. Who knows? With this radio telescope, we might actually be able to capture signals from the Big Bang directly. Another significant advantage of placing the telescope on the far side of the moon is that it would be free from interference caused by Earth's ionosphere, as well as noise from satellites and radio transmissions. Even solar radio noise during lunar night wouldn't disrupt the data collection process. If constructed, this radio telescope would become the largest of its kind in the entire solar system, giving us the ability to listen to the universe's oldest and most ancient secrets. So I would like to say only one thing to you about this video. This is your channel, please subscribe it and take it in the list of top channels soon.